Okay, so introducing our panelists once again. We're very lucky to have the panelists here. So first, we have Dr. Anthony Joseph, the Chancellor's Professor in Electrical Engineering and Computer Science from UC Berkeley. And as he introduced, he worked on bioinformatics work, on genomics, cloud computing, networking, cybersecurity, and he runs a world-renowned lab. And sitting next to him, we have Dr. Isabelle Moulinier. She recently joined Capital One as Senior Director of Data Science, where her team focuses on applications in machine learning, data mining, and credit card space. Previously, she was the Innovation and Research Director at Thomson Reuters. And she led a team of researchers developing information retrieval, natural language processing, and machine learning capabilities, and transferring their research into products such as Westlaw. And I know she's a champion of mentorship because I met her last year at CRAW down in Washington. And when I invited her, she right away said, yes, I will come. And she got us a mentoring sponsorship from Capital One. So we're very honored to have her. Next to her, we have Dr. Funda Günes, sorry. She researches and implements new data mining and machine learning approaches for SAS, and they will have hands-on labs and tutorials tomorrow, so we're really looking forward to that. In her previous role at SAS, she helped promote SAS statistical procedures and establish customer relations with a direct link to R&D by writing papers, creating web examples, and giving expository talks on new modeling and estimation techniques in SAS. So her research technique include regularization in machine learning algorithms, Bayesian statistical models, mixture models, deep learning, and stacked ensemble models. And her PhD was in statistics from North Carolina State University. Next, we have Jen Wortman Vaughan. We already have many introductions of Jen, so I think I'll leave it, but she has quite the impressive resume and experiences, and she also co-founded Women in Machine Learning, which I have attended many times and saw her speak there. She's wonderful. And last, we have Mario Guajardo-Cespedes. I try my best, thank you. From Google Research, Mario has very graciously offered his time to come and mentor. He is currently at Google Research focusing on applying machine learning on using deep learning to model language and conversations. So Google is doing excellent work in that. In his previous role at Google, he has helped take projects from early stage long-term work areas like ride sharing, mobile search, and data center networking. He also contributes to mentoring and advocacy efforts and uses technology to solve tough social issues. He has a master's from UT Austin in computer science and undergrad from UT Brownsville, and he grew up in Mexico and loves to travel and learn about other cultures. Okay, so these are our mentors. Let's give them a big hand of welcome. Okay, so just to start off, I have a few questions prepared, and if you have questions, you can sort of raise your hand, and we'll bring one of the mics over. So if somebody wants to help me with the student mic, and then I'll handle the panelist mic. Okay, great. So first question is, what is this current state of data mining and machine learning, because some of you are machine learning experts, and what insights do you have about, what data mining and machine learning is like now and where it's going? Panelists. And in the meanwhile, if you guys can think of questions to ask.
Who wants to start?
I know it. I'll jump for everybody. Is it on? Yeah, okay. So I'm in industry, and there is a huge AI hype right now. And it goes back to Jennifer's slide about what machines can do. They're going to take over the world, and then we're going to be slaves to the machines. Part of my role is to try to tell the business people, no, that's not what we do. What we want to do is really what Jen's presentation was about, is combining the power of machine when they're good at it and keeping the human in the loop when they're good at it as well, and making kind of superhumans in making decisions. And so I see this human interaction between machine and human, and the decision making being one of the future of applied machine learning in the industry. There is a lot of work around deep learning right now, which is super exciting. And it looks like it might replace humans, but I'm in an industry where we're regulated and we have to explain to the government some of our decisions, and machine learning is not, deep learning at this point in time, I'm not saying that it's not feasible, is not helping us doing that, and so we need to go to simpler models that can be explainable and understandable. And for some reason, people think they understand logistic regression or linear regression, so that's what some of our models are still using.
So data mining. So 5 years ago, I took a left turn in my career and started working on bioinformatics. So my background is in computer systems and in computer security. So why would I start working with genomic and genetic data, something that at the time I knew nothing about? It's because we reached an inflection point where a number of different things were happening. One is we're able to build massive scale computer systems that can process amazing amounts of data. At the same time, in the genomics world, the cost of sequencing a person has been dropping exponentially. Back in 2000, it was about $100 million to sequence one individual. Now the cost is down to $700. So that's to go from a biological sample into computer data. But you get raw data, and so now you want to make insights on that data. And that process of actually turning that raw data into something that you can use takes about a week of computing time on a large cluster of machines. So that to me seemed like a really interesting challenge. Could we drop the cost of computing down to match the cost of actually doing the wet lab side of the work? And so my group started on developing new types of algorithms and new types of representing genetic data. And we've now been able to take that down from about a week of processing down to 40 minutes and to do it for less than $10 per person. So now you actually have a lot of genetic data. And so now the interesting question is, what can I do with that? Well, it turns out that everybody responds differently to medicines. And we now know that there's a genetic component to that. The progression of diseases also has a genetic component, but we don't know exactly what those components are. So if we can sequence everybody, or even sequence several 100,000 people, we can now start to do interesting data mining insights on that genetic data. And so that's what really made me take that left turn 5 years ago. We're now at a point where we do have those large data sets, and we're now starting to make some really amazing insights. So for me, that's the state of data mining.
I'm from SAS, so I switched my career within SAS 2 years ago from statistics group to a machine learning group. So one of the main interests for me that in statistics, we always build models on very strong assumptions, and I thought, but my background in statistics was more in predictive modeling and regression methods, so I thought it would be a better fit for me. So I can tell you what I see in my company, what is changing in the data mining world and machine learning. With computers getting more and more efficient, I see the field is moving really fast. Like in the deep learning part, now we can use GPUs and such. So there's a big focus on automation and also getting the performance higher and higher. But while doing that, we also recognize that the interpretability of the models are very important, feature extraction, and building a model with less and less human interact. So we are focusing more on that part to build models with less human interact, but at the same time, enabling users to participate in that model building process at some points too.
Do you want all of us to answer all of the questions, or let me just? So Isabelle basically stole the answer that I would have given here. I think we're totally on the same page here, which is that, there's clearly just a lot of hype going on, and we need to get more humans into the loop. But one thing that I want to add to that is a difference that I've noticed just in the past couple of years, is that, so aside from all of the technical innovations that are going on, there are clearly huge technical innovations going on, and, deep learning among them is having a lot of applications, so I don't think it's the right thing for everything. There also has been a bit of a social movement, I don't know if that's the right term for it, but there is a lot of kind of public interest and, media interest and policy interest in machine learning that I think is just really building up over the past couple of years, where people in the general community are, worried, perhaps legitimately, about things like the amount of automation and what that's going to mean for jobs. I mean, I think this fear of automation and what it's going to do to the economy is a lot more of a real legitimate concern than some of these concerns that people have about robots taking over and all of these things. And at the same time, people who work in policy, who work in law, are starting to really take note of the fact that machine learning is being used in all of these decisions, and they're starting to care more about issues around bias and around fairness and interpretability for the sake of these things. And I think that one big area of machine learning that is growing and is going to continue to grow is just kind of the social side and the policy implications, and understanding all of these things, and understanding how machine learning is affecting our day-to-day lives and what that means and what we should do about it.
Okay, great. Okay. All right, thank you very much. And just a follow-up question. I know some of you has answered that already. Where do you see machine learning and data mining going in 5 years if you were an oracle? Or what are some really exciting things in machine learning and data mining that's coming up that you think we should, students who are looking into choosing a topic, or students who are working, what are some things they should look into?
Yeah, so I guess stealing for your slide about imposter syndrome, the first disclaimer, I was introduced as a researcher, and you will notice I only have a master's, so I'm actually not a researcher, and just want to put that out, that I feel like maybe a lot of these questions I might not have the most insight, but at least maybe I can bring a non-research perspective to that. I'm more of an applied person, and I've done many reincarnations, and deep learning is the latest for many reasons. So I haven't seen a lot, even though I'm now embedded within Google research. So just take that into account from what I say. I think for me, what I've seen so far, and I will answer more like kind of the personal side of it, is that a lot of the times I felt I had to choose between working on something that I felt helps the world. And a lot of things help the world, but it was always the question of how directly do you help, and how many layers of indirection. And I think in the next couple of years, or even today, maybe what Jen was alluding with ML fairness and whatnot, is I feel myself, even without like a PhD and stuff, being in a position to be in between researchers and people who work in product, and really kind of coming and with a different angle, and kind of being more inquisitive and say, hey, how will this affect like millions of people, right? And when we are in those positions. So for me, what I feel will come in the next maybe 5 years is that perhaps a lot of these questions is because maybe to some extent there are things that are on their infancy and other things that are more mature. I feel now we are in the position that in those 5 years we have the opportunity to have the right tooling, to have the right systems, and I feel very excited about like being able to be in that space and make that contribution. And I feel that gap between helping the world, not to say other things don't help the world, I just feel like sometimes maybe the stakes are a little bit higher from what the algorithms are deciding is, I feel that on one hand, some things might take longer, so sometimes we underestimate what happens in a year, but I think we overestimate what we can do in a year, but sometimes we underestimate what we can do like 5-10 years. So I think we'll be in a good shape. Not that necessarily it might be in a clean way. It ties to, I don't know, our countries and politics and whatnot. But I feel like in 5 years, the right people will continue working on the right things and will be much more equipped than we are today.
I'm going to skip the part of the question about making predictions about where things are going to be in 5 years because I have no idea. But just in terms of what people should be learning, what people should be getting into, I just want to put in a pitch for more interdisciplinary work, which I think is greatly needed and greatly valued. So I think that there are a lot of people who are kind of learning machine learning, but the people who have the real edge now are people who know machine learning and know other fields and really can put together this knowledge. So in particular, I think there's a real need now for people who understand machine learning and understand the law really well. And there are very, very few people who have tried to get real knowledge of both. There's a real need for people who understand ethics and the entire history of that field and machine learning. There's a real need for people who understand social science and they can use tools from machine learning, develop their own new tools from machine learning and apply it to their field. So I think that's a great way to have a lot of impact.
I agree with Jen. I feel like even though machine learning algorithms are getting smarter and smarter, computers are getting more efficient, the field knowledge in different areas are the most are the ones that will make us more valuable. Talking to different people from different companies like Netflix, Quora, it all comes in the end that what makes them really good in their work is that they really know that field, they know what their customers are looking for. So when they improve those algorithms, they know in which direction to go. For example, if they are doing some feature creation, that knowledge plays an important role. In healthcare, it's the same. So I agree, just alone machine learning is not as valuable as doing it with some interdisciplinary field.
Can I pass? Yes, no problem. Otherwise, policies might be better in 5 years. I'm not sure because it moves really slow and it depends on political movements as well. But one thing that would be exciting is as the machine footprint grows, we've got more machines to compute. We have more power, but that power is taking a toll on the climate and everything. So what I'm hoping for in 5 years is seeing Anna's research in production.
Actually, to add to that, I think in terms of research over the next couple of years, one very interesting area is machine learning using hardware. So not just GPUs, but also custom hardware like Google's TPU. One of the reasons why they did the TPU chip was because just to do 4 minutes of speech recognition for their users a day would have required them to double the number of data centers they had globally. So that gets to the power side of things. So I think that'll be a very interesting area of research, looking at hardware acceleration for creating models and also for serving models. I also think pushing machine learning out to the edge. So you have machine learning in your phone, and it doesn't necessarily have to require going off to the cloud or into other types of IoT devices. Right now, everything is done in the cloud. Very little is done on the edge. Also, in terms of where I think machine learning will be in 5 years, it will be improving our quality of life. So I mentioned the example of precision medicine, but there's also a lot of interest right now in autonomous vehicles. And I think it's really, everyone's focused on we can sit back and read our email while our car is driving. But in the US alone, roughly 30,000 people die every year in automobile accidents. So if you have autonomous vehicles, hopefully that number goes much closer to 0. So I think those are some of the areas that are going to be very hot over the next 5 years.
we have a question here.
I just wanted to talk about interdisciplinary side of machine learning. You just mentioned that that it's kind of essential in many of these domains. You said bioinformatics is closely interacting with machine learning groups right now because there's a strong need, and there are many different areas where that is happening. Jen mentioned on the policy side, the lawmakers want to, I guess, maybe regulate that area or somehow interact with those groups. And so the question is, how do you see that happening? Do you think that the different domains should work together as a research group? Because machine learning itself is also a merger of computer science and statistics. So if you work in the medical field, let's say bioinformatics, or maybe neuroscience, you need both those domains led by someone who understands them in depth. So for bioinformatics, you need someone with a strong medical background, and then obviously the machine learning expert. And for law, that's you can't have the same person a person that has a law degree, statistics, and computer science pushing the boundaries for neuroscience as well. Becoming somewhat decent in neuroscience takes probably at least 10 years. And then you can't have the person with a neuroscience degree, computer science, and statistics. So how do you see that happening? Do you see different groups interacting, or do you see certain researchers diving deeper into both fields?
So I think it's all of the above. So I look at my experiences, and we've done both. We have the Center for Long-Term Cybersecurity, where we are bringing together people doing machine learning, social scientists, government and public policy, legal experts, and so on. And so I think you'll see organizations like that. And then in my own research with bioinformatics, one of the core members of our group was a person who had a computer science degree and also was in the process of getting his MD. So he's a relatively senior person because, as you pointed out, it takes a lot of years to become an MD. It takes a lot of years to become an expert in computer science. So I think you'll see a combination, groups that come together and bring expertise in multiple disciplines, and then individuals who gain expertise in multiple disciplines.
So I'm going to give an example from the legal domain. So in my previous job, I was actually providing tools to legal professionals. And there is a small movement out there in the schools, law schools, to introduce the students to computer science early on as a tool to help them make better decision and better argumentation. And I think there is a professor called Daniel Katz, I think he's in Chicago, I can't remember where exactly, who's really advocating to change curriculum in the law school in order to enable the use of technology in that field.
I feel like to get prepared for that academically and while doing PhD or undergrad program is very important, but I feel like the most part of it actually happens in the workplace too. You may not get to the level of the expertise, like I work with MDs on consulting projects on cardiovascular diseases. So like staying curious, asking the right questions all the time helps a lot too. And big part of it is the communication between those people that you're trying to solve their problems. But I totally agree. I feel like there will be more and more departments offering minor degrees that focusing on the machine learning side too.
We have.
I just wanted to add one thing super quick, which is that, you know, yes, it is difficult for one person to become an expert in these different things, but it's also, I mean, interdisciplinary work is just difficult generally. And even if you have people who are both experts in their own specialized area who just want to collaborate, that's something that's still going to take a lot of time. They can't just come together and immediately start talking and work out this brilliant collaboration. Like, it takes so long just to even understand somebody else's language and understand like what types of problems are important in their fields, where the emphasis is, and all of this. So I think, yeah, I agree with what others have said about needing both, but I think both are actually difficult in their own ways, but worth doing.
Yeah, I think for me, just one side. More formally, I think the group I'm part of, we have a wide range of kind of characters, people who like are musicians and people who design games, people who are linguists, and people who like do deep learning. And I think our group is like, we've been kind of very intentional in kind of being multicolor in terms of ideas. I think there is, what I've observed, maybe other groups, maybe there is temptation to become more monochrome and kind of have big wins on things that are pretty hot. So I think is a temptation, and I think as an organization kind of making that a priority. It's not easy, and I don't see it everywhere, but just to say, like, I feel I'm kind of fortunate in that area. More personally, I feel like, and I like also to bring it tied to the mentorship piece, kind of just like, I feel a lot of times, I think is you can step on the boundary of what's kind of okay or not, and I mean in a positive way. Like sometimes I think we self-police each other too much in our careers. And for example, one brief anecdote, when I was doing my master's in computer science, I was a teaching assistant there for classes and everything. I'm from Mexico, but I took this internship to go to India, and I live with half of the people were engineering, the other half were MBAs. And it just kind of changed my mind of, hey, how do business people think? I came back and I took a couple of courses in outsourcing in the MBA school, because I look at my degree and say, you can take classes anywhere, right? So just kind of read the fine prints of what you can do. And then I went there and I said, well, I kind of like how they are kind of more people-oriented. I'm not so excited about the business side. And then I asked a mentor, tying back to mentorship, and he said, you know what, why don't you experience the field of nonprofits? And for me at that point, nonprofit, I didn't have a complete picture. It was more like people like I don't know, asking for money for Red Cross and stuff. It wasn't like kind of what I understand now. And he said, go back, find a course, see if you can find a professor or a mentor. And I went back and I looked in the curriculum. It turned out that there is a course in nonprofit strategy offered in School of Public Policy. That I look at again at the fine print, and they didn't allow me. It was like too out there for computer science. But then, and that's what I mean in stepping on the line. I went with the professor and I said, look, I just have this desire to learn. Any way you can let me help you in whatever capacity. This professor was in the committee for the Turing Awards, and he sat in the intersections of public policy and telecom and computer science and networks. And he said, I have this thirst of people with computer science background that don't show up to the School of Public Policy. They come from the social sciences. So it was a perfect partnership. We worked for a year, really enjoyed. Again, it's not on my curriculum. You won't see it there. What was allowed is to take a course there in nonprofit strategy. That professor got me an internship to do IT consulting to help nonprofits become better. Long story short, I feel, and even when I interview with Google, they asked me, hey, do you know about post versus get? And I brought this kind of policy side. And what I'm trying to say, like, there is a spectrum. You can sometimes spend a whole career and a PhD doing that, but I feel this kind of shorter engagements and just stepping on the boundaries of like, hey, just dare yourself to follow your heart, and at the end, you know, like I was a TA in CS that paid education and stuff, but my heart was somewhere else, and it's not like that was bad, or it was just different. So that would be my advice for all of you as you find this. You don't need to commit your full life, and sometimes you do, but just find ways to do things that make you really excited.
Thank you. One question over here.
This is sort of a quick follow-up to the previous question, but I'm somebody who's going to be starting my graduate degree in the fall, but I also have like some interest in, say, like behavioral economics and psychology. And so would a suggestion be to, say, follow through with all the technical stuff first, so the stats, the math, computer programming, before learning, like, say, some of the domain knowledge, or concurrently, or say a little bit of both here and there?
So I'm going to say it depends on you. And what Mario just told us, he kind of followed the course of his master's, but he also looked for external opportunity to get some of those extra skills. And so it's a personal choice, in my opinion. This said, having good bases is always a good thing. So the math and things like that.
Yeah, I would echo that. I think, follow your own path, get a good grounding, and that will help you a lot.
I can talk loudly. Oh, right, sorry. So I was wondering, you guys have talked a lot about interdisciplinary sort of approaches, and I was wondering how that has changed your communication style from maybe your the silo discipline that you were working in to now communicating with people from across the spectrum, from sociology to policymakers to, sort of engineers, doctors, lawyers, et cetera.
That's a good question. So I can't say that I've been talking to policymakers and stuff, but I've been talking to a fair amount of lawyers. So when I started a long time ago, I was very detail-oriented, and all I could talk about was the details of the algorithms, the features. And I've learned that, except for my coworkers, as soon as you say anything that looks complicated, people glaze over. And so what I've learned to do is abstract to a level where I think that now I'll admit I'm a hand waver, and make it simpler for people to understand. And so sometimes it's simpler by taking examples and abstracting the details. Sometimes it's simpler by really trying to understand what the problem on the other side is. And so I don't think there is a magic solution for that, but it's really try to understand your audience. And so if you're talking to lawyers, what's important to them, and why should they care about what you're telling them? Or any other area that you're not familiar with.
I'd say it's like trying to explain something to a family member. They may not, their background is going to be very different, and so, as was pointed out, trying to relate it to their background will help you with that process.
So just to follow up on interdisciplinary work, so research and researchers may be evaluated differently in an interdisciplinary environment, and different departments are having a lot of trouble trying to work with these interdisciplinary bounds when you have tenure and all these other things to deal with. So how do you feel researchers should be judged in an interdisciplinary environment, and research should be judged? So for example, should researchers go back to their home domain and publish there? Which is often what happens, or some other strategy?
Yeah, that's a really good question. So it depends on your state in your career. So post-tenure, it's very easy to work interdisciplinary. If we do a senior hire, for example, at Berkeley, they could be 50% stats, 50% computer science, or some other department. Pre-tenure, I think it's really critical to have a home department. We usually don't do joint appointments across departments because you run into the situation where, if someone's 50% stats, 50% CS, their tenure case goes up both through stats and through CS. And so both departments have to vote on that tenure case. So I'd say pre-tenure, you want to be a lot more focused on a home department and working within that department. Wait to do more of the interdisciplinary stuff until post-tenure.
I just want to add to that last point. I would say you don't necessarily need to totally wait to do any of this type of work until you're post-tenure, but just until that point, make sure that you are contributing to your home community. Yeah. and also, you know, you kind of asked how people should be evaluated, and I think that the answer was kind of more about how people are evaluated. How people should be evaluated is an entire different issue, and I think it would be great if we could change how academia works so that interdisciplinary work is more encouraged. But for now, yeah, you kind of have to play by the rules as they exist.
Hello, I have a question about choosing papers to read, for example. Well, if you're in your field, so usually you go to several journals, but sometimes there are some ideas that you can bring from other fields to the field that you're working on, and in which can be very impactful. If you are doing that, do you have some tips to choose to go to literature? I don't know.
I get all the right ones, yeah. That's the hand-waving part that I was talking about. I don't, but find papers that you like and see who they've cited, who they've read, who they cite. So if you're like between two areas, some of the papers will cite people from the other area, and go see those papers as well. One thing to be careful of is the language difference between the different fields. I just read something on Quora, I think, about reading machine learning articles, and people were intimidated by the math, and the advice was skip the math and read the English between the math. If you don't understand the English between the math, it could be a bad paper, or it could be that it's not what you're looking for. It is hard to go to very distinct areas. So let's say you wanted to read about legal arguments, that takes more. But when it connects or it's been used before, then you can follow that track.
Yeah, I also want to talk about a little bit of the language difference between computer science and statistics. So when I was doing my undergrad in statistics, my boyfriend was in electrical engineering, and he was taking statistics courses, and he would come and ask me questions like, oh, what do you know about that? I was like, I never heard of it. I don't know. And it turns out that like really simple rule in statistics that we use every day. So if that happens to you, don't let that. I encourage you, discourage you, and just a lot of them, the terminology differences, just wanted to emphasize.
Okay, and I sort of have a follow-up question to that as well. So how do you establish, sort of more general question, how do you establish yourself in one specific area? Like just for the students out there, you build up as a PhD student, and then from PhD you go into sort of a more senior researcher. How do you build up in a particular research area? Build up your reputation and your research and your career in a research area. Do you have any advice concerning? Sorry, do you have advice in your journey about what is a good your advice or something that you've done right in the past in building up that career?
I can take that one. My advice is don't do what I did. And so I was never focused. I really, so I went to industry right away after, so my PhD was sponsored by industry. And then as soon as I was done, I went to the industry. And so my focus area was really focused on the problems of the industry I was in. And so I can't say that I have a real research agenda. I'm really looking to solve problems, which makes me an applied person as opposed to what I would call a true research person that tries to identify research problems to solve. And so that's what I like to do, to solve problems. And I tried research for a little bit and it didn't work out, but the mix of the two is just good for me. Publishing papers is always good. Organizing workshops can help you be recognized as well. Mentoring at some point, even like mentoring doesn't have to happen when you're known or like if you have a name or anything. It's just helping other people understand your field. And so as a master's, you can actually mentor undergrads or even high school students.
So I actually want to disagree slightly with this last point. And this is just to say, I think that, you know, everybody who's in research ends up doing some amount of service in their career, but from my experience, I've seen that this really ends up disproportionately falling on minorities and women and all of the people who are already, you know, at a disadvantage in a lot of other ways. So I think, like, yes, mentoring is good. Yes, organizing events is good, but it's good, like, to a point. And that, you know, if you're trying to get a research position out of grad school, people are not going to be looking at that, right? Like, they are going to be looking at where you've published papers and how good these papers are, who knows your papers, who's citing them, how strong your letters are talking about your research and all of this. And you know, the sad fact is that most of the time these search committees are not going to be looking at your CV and saying, oh, this person was a great mentor, you know, even though this is actually something that is important when you're eventually going to be faculty. Like, the fact that you're good at advising students is really important, but that's not what they're looking for when you're interviewing. They want to see a strong research record. So I would say just be a little bit hesitant, be a little bit careful with the service, and make sure that any service like that you're doing is actually, like, something that's going to help you in the long run. I mean, a little bit of the stuff, I mean, people just like mentoring and all of that, and if you really enjoy that type of stuff, then fine, spend some of your time on it, but realize that you're making a sacrifice, right? Like, you don't have infinite time, and any time you're spending on that, you're not spending on writing another research paper. So just in terms of your career, make sure you weigh these things. And if you are gonna do something like organize a workshop that's, like, on a research topic that's super close to your interest, that can be a great thing that is both kind of service and fun to do, and also something that gets you known in the research community. So that type of thing can be a really good choice. But I mean, really just write a lot of papers and do good research.
For her advice, she was in faculty, I was not.
Question over here. So when it comes to writing papers, how do you get over being such a perfectionist that you just push the publishing, or you miss the deadline or something? And also, a second question, so I'm starting my master's, and I know I want to do a PhD. So how important is it to publish during your master's? Should you focus more on classes, or should I try to get out one or two papers at least before I go into PhD?
Okay, so when a grad school is evaluating you for a PhD, if you just have a bachelor's degree, then mostly what they're going to evaluate you on is your coursework, and if you've had research experience, you know, look at the letters from that research experience. If you already have a master's, it's a little bit more complicated, because if you come in just with a bachelor's degree, and, you know, it turns out grad school isn't for you, or whatever, you can always get a master's and leave. If you come in with a master's, then you don't necessarily, there's no sort of exit option other than, you know, you just leave. So for that reason, grad schools tend to be a lot more conservative when it comes to admitting a master's student. And so they want to see some track record of research. And so classes will be a lot less important in terms of the decision factor, because in general, most people, you know, do well in classes, and they're most really focused on, can you do research? So in that case, having a publication counts a lot, because it demonstrates your ability to do research. In addition, having letters of recommendation from faculty that aren't just, you know, you took this class, got an A in the class, but rather, you know, I worked with this student from a research standpoint. It could even have been a research project in a class, but something that says something about your ability to do research is going to be important.
When I was doing my PhD in statistics at North Carolina State University, we were like 30 people. We all started our PhD, and they all aim to do their PhD, but first you need to do your master's degree. And in the end of the second year, I think the ones that really continued to do PhD was only 8 out of 30 people. So people change their minds when they do their masters too. If you really are sure and set your goal to do a PhD, I can see that investment doing more research, but if you're not so sure, I would recommend to take as many applied courses as possible during the masters.
Yeah, so I think I kind of want to echo the similar spirit. Maybe the unasked question is, should I do one versus the other? And obviously, the intent of this message is not to discourage people, but I think it's more to say, hey, finding what you really care about. And we all have different paths, and kind of comparing to others. There are a lot of things that we can connect together. So my own path was I went to this school that is not very recognized for undergrad, right? So my options were limited. I was very fortunate that in this school I worked with a professor who he, instead of like doing research, he said, I just want to fix, it was not working, the internet on campus. So we were more like applying, doing like, it wasn't research, it was more like how can we do something to have the better network. It put some seed in my mind that it looked like a research lab because it was run by a professor, it were students, but we were not doing research. So when I left there, I really had this curiosity. Do I enjoy this lab collaborated environment, or do I enjoy the research part? So when I went to do my master's, I felt I killed 2 birds with one stone. One was a better school that will open doors. I think we haven't talked about pedigree, but I think punchline, it matters. And I just felt people will look at you differently. You're just where you go. So to your questions of should I do A or B, I would say see where there is more funding, see where you will get like better, like recognition. And after you are there, the training or whatever the training is in your field, then you can do kind of more. But during the master, the question was like, where, like, should I continue to the PhD or not? And I think the interdisciplinary courses, like anything that, and it goes back to like step on the boundary and just create yourself. That's like what happened to me was all throughout my career up to undergrad, it was very straight line. And I just felt that's the way it needs to be. And I felt when during my master was this kind of find yourself kind of period. And I think people go through that different ways. So I would say like, if you are already on the other side, you would know if it is papers or not. It sounds like maybe there is something like maybe not there yet. So maybe just give yourself that space to do that. And I think for me, I was very glad that coming out of my master's, I knew at that point, the person who I was at that time, I was ready to go and and join industry. I always reevaluate that in many questions, and you can always change, but I really like coming out with the certainty that I didn't have coming into the program.
So we have.
So there was another part to your question, which is the writing papers. I don't like writing papers. And so I've not written many papers, if not at all. But one thing I've learned from the few papers I've written is be ready for rejection. And so since I start with the assumption that it's going to be rejected, I don't focus so much on the details anymore. Which is probably a bad thing. But that's like, even if you think your paper is perfect, the reviewers might not think it is. So do your best, but try to publish. So don't miss the deadlines. Like, just try to submit is what I'm trying to say.
Yeah. So, sorry. So we're getting tight on time, but you can see that we have a table at lunchtime about writing and publishing. Okay. So if you want to talk more about that, you can sit at that table during lunch. But I think Christian had one question.
Yeah, just one last question for the panel. But yeah, so I'll make it quick. So we talked about paper writing and rejections, and I want to ask, are there any topics within data mining, data science that you think people should stay away from? So I'll give you an example. So when I started doing my PhD, somebody said, don't do anything with information integration. It's a solved problem, or you can't solve it, it's too hacky. Is there anything that you would advise students stay away from? Or is everything kind of fair game?
Anyone?
I guess you stumped us, and it's time for lunch.
All right. So thank you to our panelists. Let's give them a big hand. Thank you for answering our unceasing ending list of questions. So what we're going to do now is we're going to break into lunch.